So symmetry exists in three-dimensional models as well. So imagine you've got yourself a box, like maybe you just got something in the mail recently, because everyone's ordering everything online right now in the COVID universe. But if you were to take that box and cut it in half, like imagine you could the big knife just cut it all in one nice um, straight plane. Um, you would get something called plane symmetry. And rectangular prisms actually have a lot of plane symmetry to them. You could see in the picture there, they've got the horizontal plane, or like it's just cutting it into two cubes, it looks like. But you could have also cut it along the long axis. If you've ever seen a taped up box, you recognize that as like the tape line all the way around it. That would be symmetrical because either side that's left on the side of that plane matches itself. You could also, I'll draw this line in red here, have a horizontal plane that cuts it so the top and the bottom match up. So there are lots of different kinds of plane symmetry. They're just a little bit harder to visualize. But the easiest one is the box. It's got three of them. And the whole idea is after it cuts, it leaves the two pieces left over looking exactly the same. Axis symmetry is, well, it's kind of like spinning your finger on a basketball on your finger. Imagine there's a finger at the end of this um, cone here, and it's being held up in the air, and someone's spinning it on their finger. Would it balance when you spin it? Well, maybe not very well, but it would basically spin on top of your finger there. So that's the idea is axis symmetry is a kind of uh, rotational symmetry, um, but it's three-dimensional, so we have a slightly different name for it. And same kind of thing, you're going to be identifying those rotations or those axis symmetries kind of by degrees as well. But right now, for us, because we're just kind of learning this and we don't have many techniques to graph or calculate or look at things three-dimensionally, we're mostly just trying to identify um, the shape. So um, here we've got an L-shaped prism. So imagine you had, I'm going to check for axis of symmetry first because it looks to me like it doesn't have an axis symmetry. So if I were to draw a line straight down the middle there, well, the bit on the top would either be sticking up or it'd be sticking down or to the side, so that doesn't seem to work. What if I had one slightly higher? Let's say it goes through the edge. Well, no, that same problem, and definitely the same problem here. Sometimes the shape would be um, above the line, and sometimes it'd be below it. Definitely not axis symmetry that way. Maybe it comes through here, but there the problem is you have this long side and a short side, and if you were to rotate that, well, not only would it not be the same lengths, but you would have short side, long side, so it definitely wouldn't map onto itself. And then I'm sorry I'm kind of erasing these pictures after each one, but you just need to visualize it for a second to confirm or deny. We're not really doing much about like describing all the different things that it can do, but you get the same problem when you do it vertically. Long piece sticks out here or it sticks out on the other side. It's never going to match up with itself, except for the really boring one with 0 degrees. So here we're going to say no axis symmetry, but it may have planar symmetry. If I cut the plane in half, or the shape in half horizontally there, it doesn't quite work. There's more on the bottom than there is on the top. But there is one, and this is like the tape line on a box. If I cut this here, like it was a box and I was trying to tape the top of it back together to close it up, On the left and the right-hand side of that line, it's the same L shape. So I'm going to say this has plane symmetry. And I don't even need to label how many it is. It just has it. All right. Now, prisms, like this pentagonal prism here. Think about the center there, draw a line down the middle, and imagine spinning your finger on it. Would it land back on itself? Yeah. It's just a pentagon, and pentagons have rotational symmetry. It's actually 72 degrees. So yeah, the base, if you have a normal looking prism, right? Just a regular pentagonal prism. And the big clue here is that it's regular. If it was any prism, to where maybe one side set of sides is longer than the other, it doesn't work. But because it's regular, and that means all five of the sides, ooh, that's still not very good, are the same length, then it should match up on itself. So here I'm going to say axis symmetry. Now, does it have planar symmetry? Well, imagine cutting it right down the middle. I have one whole side, two whole sides, and then a half a side. One whole side, two whole sides, and a half a side. So yeah, that would have planar symmetry that way. It would also have it if I cut it in the middle. It just makes two regular pentagons, regular pentagonal prisms on the top and the bottom. And if you cut it in the exact middle, they should be all the same length. So this one has plane symmetry as well. So I would say this has both symmetries. And for the three-dimensional ones, it's really just, does it have one, the other, or both? Sometimes it will have neither.